So let's discuss a fashionable topic, telemetry. Everyone today does telemetry, so you instantly get bonus points if you do telemetry for whatever you are doing. And if you want to get some karma points, you need to do streaming telemetry. That's really easy. So that's the whole point of the presentation. So, on a little bit more serious note, what is telemetry? Not a new concept in general in engineering and in telecommunications in particular. That's an abstract mechanism where you can monitor some entity somewhere, in general remote, and get some operational parameters of whatever form is relevant to that entity, being observed at some other place. And in our case, we are talking about a network. We can remotely monitor some element and monitor in the sense of doing that asynchronously, that we don't need to constantly interrogate that device or that element. It on itself proactively provides you some data. This is a move away from the general concept in network manageability, where in order to find out something about the element, you need first to query it, and then you hopefully get a response. The second one is the second component of this is BGP. So BGP is really, well, I think I forgot which audience I'm talking about that. Well, everyone knows what BGP is, so we can just move along. What's BGP telemetry? So we take those two concepts and glue them together with some duct tape and WD-40 and see what happens. What is the actual real world, I would use the word problem probably here. So BGP has a history that it tends to work, and in most cases it works fine. And those rare cases when you are not too certain whether that works or not is where you would really be happy to have some more insight into what is happening in your network. Especially if we're talking about the things of BGP policy operation, how it modifies the attributes, why this particular prefix is being advertised or not being advertised, and why do you see a particular route being selected or not. There are different fragments of mechanisms. I cannot use the word solutions because those are just fragments to the solution, which have been in the industry for a long time, and they're used to varying degrees. So we have management channels, command line SNMP model-based, more modern things. We have all sorts of logs, dumps, traces. One of the more common mechanisms for that is MRT, multi-threaded routing toolkit, which can actually dump certain things related to BGP operation into a file, and that can be used later for offline analysis. Industry has developed quite a few mechanisms for using BGP for monitoring itself. So in a sense, you can run a dedicated BGP session only for monitoring purposes, which can carry all the unfiltered feeds and other attributes which normally would not be propagated to some central entity, and they can try to monitor and dissect that feed. However, this has a serious limitation that BGP by itself, by default, follows its own rules of limiting the information which gets propagated. So typically that gets after the best path. There are certain attributes which would result in updates not being propagated and so on. And in a say exception scenario, you are most interested in those particular types of events, which will very likely get filtered out here. The telemetry on a data plane is well known in the industry. It's used really widely and for a long time, and that doesn't raise any questions. This is considered to be a commodity technology. So given all of this, can we do something better with BGP than we are doing right now? And it appears that we can. So there's a dedicated mechanism, which is a protocol and a tooling around that, meant only for monitoring aspects of your BGP sessions. So it's a dedicated protocol. It's not an extension to BGP. It's not a new functionality which is carried over that same BGP transport session. No, it's a completely separate protocol. A simple one and a unidirectional one, only from the network element to an entity called collector. So in a sense, you should not be too worried that some collector or some system which you are using will send out something and flip over your BGP router. The overall approach to that is that it takes what is called the push model in the industry, that you don't need to query your device. The device will proactively send you anything, or think of it as a spam, that it will send out all the events, activities, statistics, and all sorts of other happenings which are going on without you even asking. And sometimes that might be quite an overwhelming amount of information. It's a simple protocol using simple binary encoding, which is based itself on the encoding of BGP messages. So if you have your tooling, which is able to parse raw BGP messages, it wouldn't require too much of the extensibility for you to be able to parse the BMP feed, because internally in the container, in a BMP container, you will see mostly correctly formatted BGP messages. We'll take a look at that in the following slides. And the beauty of that is that it has timestamps for all of the events, and this allows you for correlation of the events and for correlation of the events sourced via other mechanisms. So you can do things like trying to correlate the traffic flows on a data plane with your BGP operation and seeing that you, for whatever reason, start to get traffic which should not be there because you are neither advertising nor receiving prefixes for those particular flows. The way how that works, basically, whatever is happening on the BGP component is categorized in several large groups of information events and sent out to the collector. The overall approach is send whatever you can. Don't think locally on a box. Now, all of the intelligence is not on a network element, but on a collector. Don't be worried that you will overflow the collector. The collector is smart and capable enough and has much more resources than the router, which can be used for trying to decode what is being sent there. The overall approach is that the router should be focused on doing its own work, which is basically calculating the topology and maintaining the control plane. Everything else is done outside. Now, from the point of view of what information is provided, it is enough of information to reconstruct the BGP sessions. So you can do things as to even replay the BGP session later at some point in time and analyze what was happening, or we can even do things like, for example, testing or root cause analysis of what happened by replaying the traces which you collected previously. So mirroring, the functionality which allows you to save incoming and outgoing raw BGP messages. Raw BGP messages meaning before they are parsed and after they are generated by your BGP speaker. This would allow you to see things like malformed encoding, or, for example, there are quite popular vectors of attacks of trying to establish the session to an open speaker. And this very much depends on actual implementation details. Some platforms will show you that, some platforms will happily silently ignore such events. And with BMP, you have the ability to actually see a mirror of the BGP PDUs. That would be equivalent to traffic mirroring on a data plane. Some vendors call that span, some others call that mirrors, where you can see a one-to-one copy of your BGP traffic. Any errors that your BGP implementation would react, it would eventually react on that, but you will get a copy of the malformed message before it actually reacts on that and maybe falls over. Events. This is related to establishment and the tear down of new BGP pairs. The session came up, session came down. On what parameters? And what is important here that it doesn't try to interpret partial information of what is being carried in opens and notifications. It just sends out a full copy of an open and notification message with all the codes, all of the capabilities, all of the bits, and all of the machinery, which you will be able to interpret then on the collector side. It also provides some information about the overall health of the BMP component. There might be a case that, imagine you have a large amount of BGP pairs all trying to synchronize the initial view. That's quite a large amount of information flowing in and a large amount of things to be processed by the node. It might be that the BMP component or the transport channel from a BMP component to your collector will get overloaded. This will allow you, a BMP component, to signal such an event saying that I was overloaded and I have lost that many thousands of messages. Therefore, be careful with how you interpret certain missing fields on your collector. Monitoring. This is probably the most interesting and valuable aspect of BMP from the practical debugging of the routing policy perspective. It allows you to see the path of the updates as they come in before the policy and after the inbound policy, the best path processing and the results. And then what is intended to be sent out to the remote peer before the outgoing policy and what is actually being sent after you apply the outbound policy. So this allows you to do things like tracing of the path attributes. If you receive an update carrying a specific set of path attributes, you might see in time which policy and which elements in the network modified those attributes. And provided that the timing is synchronized across the elements, you can do things like analysis of convergence timing and things like that. And how does that affect the overall BGP policy? You can do on basically deployed policy validation, send, for example, a beacon test prefix on one side of your network, and then collect the BMP traces from the other elements and see whether your intended policy operates as you want it or not. Now, from the practicability point of view, this looks internally as a BGP message carrying an update or a withdrawal encapsulated in some BMP container. So if you have monitoring systems which are able to process BGP messages, what you can easily do is simply decapsulate the internal BGP message out of the BMP container and feed into that. You don't need to reinvent or modify your existing monitoring systems that heavily. And there's also statistics. A set of counters sent out periodically in general and on occurrence of some event, depending on the event type of how many of this and that you have inside of the box, how many errors, how many logical errors, loops and things like that you have encountered. And again, that's one single, more or less standardized channel into the out of the box into the management system, which would provide you the visibility into what is happening uniformly across different address families. Now, deployment aspects. The main thing, there are two components to this for the system to be practical. You need to have a generator, typically that's a router or some other network element, and then you need a collector, which aggregates all the feeds and then dissects the data and tries to find out some value out of that data. If we are looking at this time, end of 2020, most of the credible equipment vendors provide BMP support. This is not a new protocol as such. It's around 15 years as these ideas started floating, has been finalized several years from now. It was dormant for a long time. But as the industry started to see value in such more or less uniform and proactive streaming telemetry mechanisms. The BMP work has picked up that ITF. Now it's fully standardized, finished, and that's implemented by really most of the vendors which can be considered to be credible. From the collector system ecosystem, we have both open source and proprietary vendor tooling support, mostly on a good practical usable level. Overall, if we're looking at trends in the industry, BMP is becoming the standard of monitoring your BGP control plane. Now, one note that needs to be made here is it is meant for BGP. It's not intended to be a universal control plane monitoring and data gathering mechanism. For that, BGP-LS or maybe specific taps into your other control plane components is more appropriate. BMP is meant to be simple, is meant to be rather resource savvy and not to overload the rather critical component of BGP itself. And that's all done for the purpose of maintaining the overall stability of your control or your BGP control plane. So if you want to, basically, the overall idea is that you have one tool for one task. If you want to do something else, well, please use other tools. BMP itself is quite chatty. And if you looked at the previous example of monitoring, for one advertised message or one advertised update for prefix, you might get multiples, 6 in general, probably even more if you are doing some other things, BMP messages generated. And you multiply that by the number of your peers, you multiply that by the number of prefixes, and add in the amount of the path attributes that you are carrying, and very quickly that amount of information which needs to be fed into out of the local node into the collector gets quite large. Therefore, collectors in general need to be prepared that there will be both redundant information and missing information in that. And BMP itself is not a fully reliably lossless protocol as such. Again, the focus is on maintaining the stability of the topology and not necessarily having 100% accurate visibility into what is happening there. It might have impact both on network elements and also on your manageability infrastructure. So if you are really using that via out-of-band management network, that's probably not the best idea. So condensed set of questions which you wanted to ask, but evil moderator put you on mute. Therefore, we'll quickly go through that list. So why is this using a binary and rather proprietary encoding compared to my favorite pick, whatever you have, the pretty transport encoding? For efficiency. The router is not the good place to generate pretty formatted JSON. It better sends out the data that needs to be sent out quickly, and then all the pretty formatting and slicing is done on the collector side. So what if I lose my BMP session? Well, if you lose your BMP session, you lose your telemetry data. BGP itself will continue to operate as if nothing happened. There are some implementation aspects. Some implementations might buffer some messages. Others will just quickly drop that. But in general, there is no impact and direct correlation between the BGP and BMP sessions. So you lose your manageability. Most probably your network will operate. Is BMP lossless? No, and not necessarily fully lossless. There might be conditions where BMP generator itself is overloaded. There might be conditions where your collector is not able to process all the incoming feed. There might be all sorts of other things where your generator will think that it has sent out and your collector hasn't received that, and you need to be prepared for that. At exactly the same time, you need to be prepared for receiving a multitude of what might seem duplicated information. So in that particular example of BGP monitoring, route policy monitoring. If your route policy does not modify path attributes, you will receive the same message for before policy and after policy event. Therefore, you will receive two updates which seem mostly exactly the same. So can we run BGP session to the collector instead of all of this new fancy thingy? You certainly can, but you need to understand the limitations. BGP itself provides a very strict filter of what information it sends out. And in general, only the best paths. Yes, you can run multiple paths with that. It will also filter out those attributes which are semantically incorrect. It will also filter out the broken things, most probably the ones which you are most interested in. Yes, certainly, BGP is used as a monitoring protocol for monitoring itself. It's just not efficient. Is this deployed at all? Yes, definitely. Deployed in many places, and I really recommend you to do that. It will solve many of your visibility problems into your control plane aspects. Well, if I'm a highly certified engineer, I type command line at 3 a.m. in the morning. I see no problems with that, and I think that my BGP works perfectly well. You might think that your BGP works well. Do you really have insight into that? Do you have sufficient and, say, implementation neutral mechanisms to check whether your routing policy is working as intended? Maybe you do, but most probably that's just an illusion. Therefore, this is a mechanism which might provide you some visibility. The fact that you may type commands at 3 a.m. in the morning is perfect. This is not trying to steal the command line away from you. Why it is not model-based? Again, the same reason as we have that for a proprietary binary encoding. It's too heavy. It's a simple protocol for a simple task. Let's not overcomplicate that. If you want to translate that data then into some other format which will be consumed by more model-based consumers, do that on your collector. It has much more resources. Will BMP help in any form of hijacks, attacks, and all sorts of other bad things? Directly, no. It's just a tool. It's just a signaling channel. The way how you can use that information carried over the signaling channel, certainly it can. And one of the very simple examples is that you might correlate your traffic and your updates. And if you start see discrepancies in the data plane traffic and what should be there based on a control plane, you might raise some alarms. So this seems to be a really heavy protocol carrying a lot of data. Yes, that's correct. If you want to have detailed visibility, you need to have a lot of data. And does it have any privacy concerns related to this information? In general, yes, everything has a privacy concern if you send out something to the other side. Now, if we are talking about the global address families, that information is mostly public. You can see that in many locations, collectors, exchanges, and other places. If you are talking about private address families or something used internally within your environment, this is a question of whom do you trust. If you trust your peer on the other side, you probably trust the information which you are sending and receiving from that side, past the filters of a certain level. Exactly true is for BMP. Does that mean that you need to open this information up globally? No, certainly not. This is mostly for your internal consumption. One of the possible use cases is to provide a dedicated BMP feed, filtered BMP feed related only to a particular peer, back to that peer itself. This way, this would provide you for a mechanism of remote side to be able to check how the policy is working on their side. So basically, whatever they advertise, that information can be fed back to their side. And that's mostly approaching the end from my side. So if you have any other remaining questions, I'm happy to discuss that. And what would be interesting from my perspective, so if you are planning or considering deploying BMP, and if you research that, what do you think is missing from architectural point of view? If you are already deploying that, probably beyond the platform implementation aspects, what is missing in the current protocol as it is? So I think that's it from my side.